This question says, what is the concentration of OH minus in a solution with a pH of 6.84? There are several ways of doing this problem, and if you haven't watched the previous questions, it's probably a good idea to start with those. But the first thing I'm going to do is I'm going to find the pOH, because I know that the pOH equals the negative log of the concentration of OH minus. Now, if you want to reverse this equation, what you want to do is first multiply through by -1 or divide through by -1. So the negative pOH equals the log of the OH minus concentration. Then, to get rid of the log, you take the inverse log, which is 10 to the power. Alright, which on most calculators is the shift log. So what you find is ultimately the concentration of OH minus equals 10 to the negative pOH. It's also worth pointing out that the concentration of H3O plus equals 10 to the negative pH, which is used as well. But in this case, what we want to do is we want to find this. But in order to find this, we need to find the pOH. Well, the pH plus the pOH equals 14. Said another way, the pOH equals 14. You can use as many zeros as you need, minus the pH, which in this case is 6.84. Alright, so it's going to be minus the pH. I should have written that down. The pOH equals 14 minus the pH, which is 14 minus 6.84, which in this particular example is 7.16. Now I can find the concentration of OH minus equals 10 to the negative 7.16, which is going to equal 6.9 times 10 to the minus 8 molar. Note that in this case, this 7 is not a sig fig. This only has two significant figures. These decimals are significant. This is this 8. Note that it's an 8 here because this is 6.9. If this was 1 times 10 to the minus 8, then this would be 8.00. But because it's 7.16, this number has to be greater than 1. And the 8 is here instead of the 7. So that is basically how this works.